Hello, Math 126 students. Part 3 of our Reverse the Order series. Let's go here. So watch my previous videos if you still are having trouble with this topic, but it's all about drawing the region. This describes a region. These inner bounds tell me the function. So this is saying that the top is y equals 9 and the bottom is y equals x squared. So those are the things I immediately graph. Y equals 9. Y equals x squared. And I'm going to shade between them. How do I know where to shade? That's where the tick marks come in. So from 0 to 3. And I can see they hit at 3. So there the region was described in terms of x, in terms of the top bottom. Now I'd like to describe it in terms of y. So now we're going to label y, and we're going to find a pattern based off of y. But y goes all the way from 0 to 9, and then based off of that, x goes from here to here. So x equals 0 to x equals, well, whatever that is when we rearrange it, square root of y. So this is the square root of y, this is 0, and we're done. The question on the exam might have asked us to compute, but here I'm just focusing on reversing the order. Done. All right, let's do another one. I remember this particular one caused a lot of students trouble because there wasn't a 0. Something about it threw them off, but the process doesn't change at all. The things we are going to graph, let's go. We're going to graph y equals 7. And I don't care if my graph is super accurate. I'm just going to draw a line and call it horizontal line and call it y equals 7. And then this, and I remember students kind of complaining after the exam. They're like, how are we supposed to know how to graph this? So I do have a video on graphing, but that's a parabola. It's a sad parabola. If you really don't know how to graph it, then plug in some numbers. When you plug in 0, you get 16. That's really enough for us to graph it. When it's 0, it's 16, and it's a sad parabola. That's enough. It goes the other way, but I know my tick marks are 1 to 3. So I'm going to put a little 1 here. Put a 1 there, and 3. So I'm kind of curious what happens when I plug in 3 here. If I plug in 3, I get 16 minus 9, which is 7. Oh, that's good. It's actually where they hit. So that's it. That was the hardest part of that, was graphing, but it's really not worse than the other ones. Okay, once you have it, then you switch gears and say, now I'd like to describe it in terms of y. In terms of y, what's the smallest y can be? It's 7. What's the biggest y can be? It's 16. Not 16, so I'm about to make a mistake. 16 is where the graph goes, but that's not the top of the region. I was about to make the mistake that many of my students made. How could I figure out what that is? So we have a puzzle here. And this is all about just graph reading. So if x is 1 and you're on this graph, can you figure out what the corresponding y would be? Being very suggestive. Y must be 15 right there. Okay, so now we have it. It's all about reading graphs. I know that that scares people, but it's worth your time to study that. It's more valuable than anything else we're doing in the course. The ability to read a graph carefully, especially if you're going into the sciences. So if this is troubling to you, come to the Math Study Center, talk to a tutor, go to Clue. You want to get this down. Okay, so we're saying the integral from 7 to 15. That's when I'm in this region between there and there. And then I want to do the integral. And then I need the left and the right. What is the left? Every point on this left is x equals 1. And then if I mow the lawn and go to the other side, I need to know what this x is. So I need to do some rearranging. When I have a negative like this, I tend to like to add it to the other side and then subtract the y. That's just how I always think about it. So x is going to be plus or minus the square root. So, the challenge here was that it was slightly more involved to solve, but not dramatically. And it should be a positive x, so it's the square root of 16. How do I know it's a positive x? Because that's where we are on the positive x side of things. F of xy dx dy. So there you go. You don't have to, it's the same process. Doesn't matter what else is going on, or even if it looks different, the same process. Now, this particular one here at the bottom, I provided a picture for it. In fact, several of these ones in these videos I provided pictures for on the test, but I wanted to talk about, well, usually when I'm doing that, I'm trying to save people a little bit of time, but we can do these without a picture. So let's try this one. Here's x. We are saying that x is between, let me use a better color, x equals y over 2, that's the right, and x equals y over 3, that's the left. I know I'm trying to go off the screen here. Okay, so those are the things I need to graph. I could say rearrange them because I know I'm going to eventually anyways. And I'm going to graph y equals 2x and y equals 3x. So here's y equals 2x. This is a more challenging one slightly, and you'll see why in just a second. Not because of the drawing. Drawing's always the same. Just draw. Okay, y equals 3x, so steeper. I'll exaggerate it a little bit. And this is just harder to draw slightly because the question is, where do we stop? Well, we're going to go from y equals 0 to 12. If you think about cutting these things off at 12, you're going to have this horizontal line here. And students that have been paying attention realize why this is a little more challenging. It doesn't have to do with the fact that it's lines. It doesn't have to do with the fact that there's two equations. It has to do with the fact that the top changes. And so this is a little more involved simply because it's going to be more work to label. If I am forced to label it in terms of x, which is what the exam question was asking, the pattern is different. The pattern to the bottom is always the same. It's always to the green, always to the green. So that's not so bad. The pattern to the top changes. So let's label that. If you go from here to the top or here to the top, it's different. Okay, so now I need to figure out where those things are, and then I'm just going to describe the region. So any of the x's between here and here on this side were between green and orange. So can we do that? Yeah, so we can say, let's first find where that point is. That's when y is 12 in this equation. Again, this is all about just being able to read graphs. If you're good with graphs, then you immediately know that's at x equals 4. If you're not good with graphs, you don't know that. This is something you really want to get good at, though. Not just for this course, for all your courses. If this is 12, then x is 6. So I know this is at 6. Okay, so from 0 to 4, the bottom is, maybe I'll use the colors to really emphasize it. The bottom is 2x and the top is 3x. And what is it? G of xy is what we're calling it. G of xy. And now we did do y dx. And that will find the volume above this stuff. And then separately, we're going to add the integral from 4 to 6. The bottom is still 2x, but the top is now whatever this horizontal line is. That horizontal line is y equals 12. We are describing regions. That's what all of this is. All right, I'm going to stop there. You can find many, many more examples on my review materials. So on my website, you go to my 126 materials page. There's 2 different links to more and more practice. And then within my 15.2 review sheet, I have like 2 columns of these, and you can try to match them up to see which ones go together. So there's a lot more practice if you need it, but it's really about graphing regions. I hope that helps.